we got a little bit of things to talk about today, specifically NGS's current plan to replace our existing datums for the United States, which is the North American datum of 1983 and the North American vertical datum of 1988. I'm not going to get into, obviously, the nitty-gritty and deep into the weeds on this, but try to get a little bit of an understanding about sort of where we've come from, what got us to the situation that we're in today, and we'll explain what that situation is, and what our plan is to resolve that situation, and then also looking at some ideas about, and hopefully during this presentation, you'll be taking in the information that I'm providing, but also thinking about how that is going to be, what kind of effect that's going to have on your workflow. What kind of things do you need to think about? And more often than not, these are things those of us in the geospatial arena need to start thinking about sooner rather than later. It usually comes down to, if I collect my data a certain way today, that it makes it easier for me to use a different way tomorrow. So hopefully this is getting the word out soon enough that folks can get a head start on that. So just really briefly, just as an introduction for myself, I'm not sure who all is online, but many of you may know me from my previous life working for the Vermont Agency of Transportation in the Geodetic Survey section. And then for about 15 years, or not 15, I'm sorry, a little bit less than that, about 12 years, the advisor for the NGS advisor for the National Geodetic Survey. Currently, NGS has changed its advisor program, so it's now a regional approach. So you can see me up there in the Northeast. I currently am the advisor for the 6 New England states, New York and New Jersey. So if you're online from outside of Vermont but inside New England, you now have a contact to NGS. So what does NGS do? I think a lot of folks think, I won't say it that way, I think a lot of folks have an idea of what we do. But by definition, our mission is to define, maintain, and provide access to the National Spatial Reference System. And the National Spatial Reference System, in essence, are these quantities. Okay, latitude, longitude, height. We're all very familiar with those. Scale, gravity, orientation. Maybe not so familiar with those, but they obviously play a large part when you're talking about geospatial positioning. But more and more, it's also their variation over time. As we all know, and we'll see very briefly here in a minute, that we do not live in a static world. We live in a world that moves. Even on the micro scale, things aren't stationary. So for us to have a coordinate system that assumes that nothing is moving maybe is convenient, but in many ways not very practical. So just look at a couple things as far as our definitions. Horizontal datums, we think of NAD83 quite often as the horizontal datum because most folks use only the two horizontal coordinates from that datum, latitude and longitude, but it does consist also of an ellipsoid height in the more recent versions of NAD83. So really our last horizontal datum was NAD27 or the first realization of NAD83, which was in 1986. We have a one-dimensional vertical datum, currently Navd88, or sometimes local tidal datum if you're out on the, if you're working along tidal rivers or on the coast. And then we have our geometric datum, which is what we really use today, which consists of a latitude, longitude, and ellipsoidal height. Those would be the more recent realizations of NAD83. I'm sure many of which you're familiar with. NAD83 96, 2007, and 2011 are predominantly the ones that you'd be familiar with, I would think. And also, we're really getting into this realm of dealing with a four-dimensional coordinate system where we're incorporating the latitude, longitude, and ellipsoid height as we do in this geometric datum. but also how those coordinates change with time, so essentially applying velocities. And on the international frame, we can look at this in an international terrestrial reference frame, since ITRF 00, for instance, or 08. And there we're looking primarily at the velocities of the plate, so incorporating plate tectonics. And obviously, on a large scale, that becomes very important for accurate mapping. So what is a datum? We have a couple of different definitions that we could draw from. One is nothing more than a set of constants that specify the coordinate system that we use. The other would be the same definition, but incorporating the coordinates, the lines, the points, the directions that have all been done via measurement. So one is the math, the other one incorporates all of the datum points, or all of the coordinates that we use to realize our datum, that we use to access the datum. So NGS has used that first definition. And the primary reason, and I only bring this up because I quite often hear folks say, oh, NGS changed the datum again, or they released a new datum. And I just wanted to sort of set the story straight a little bit, is that we only have one datum, which is NAD83. We may have many different realizations of it, or many different versions of it, but it's still the same datum. So we've used that first definition specifically or intentionally for the purpose of not having to change our datum, as Ivan will talk about in more detail, because we have things like statutes that say you will use NAD83 Vermont State Plane Coordinates. Well, if NGS every few years changed the datum, that would make the maintenance of the Vermont statutes, or all the statutes in the United States, very difficult to attain. So we have opted for just that first option of datum, where we can specify the math and then have different versions of that datum. So just an idea of sort of where we came from. Okay, so NAD83-86 was our first realization of NAD83. That was done almost entirely of classical observations, right? So mountaintop to mountaintop, tower to tower, long-range distance, triangulation, excuse me, horizontal angles, etc. Later in the 90s, we started to use GPS. So here in Vermont in 1992 was our first high accuracy reference network, which utilized GPS observations. And then later on, we started to incorporate the use of the national CORS, or continuously operating reference, GPS reference stations, which had some impacts on our datum, or on the realization of our datum. So we've had a few different realizations that were tied directly to CORS, predominantly to begin with NAD83 2007, and its CORS counterpart, which was CORS 96. And then up to our current epoch, which is the NAD83 2011 epoch 2010.0. So you notice now we're incorporating this idea of an epoch, and we'll talk about that really briefly, just so that we have an understanding of what that means. So one of the questions that we get often is why change? Why do we change datums? Why do we recompute things? I mean, everything works fine, in my backyard. I got finger quotes up in the air here. So, why do we have to change things? Well, remember that NGS, its mission is to define and maintain the coordinate system for the United States. So even though everything works great in my backyard, it doesn't mean that it works well between my backyard and my neighbor's backyard, or my backyard and the guy's backyard in the next county, or the next state, or from coast to coast. So our work really incorporates the ability to have accurate positioning at any scale across the area that we're responsible for. So if we go back to earlier, NAD27, again, based on very old observations, an older system, an older idea of what the Earth looked like. Along came NAD83-86, again, it was based primarily on the same observations, but a new system. For the first time, we really were sort of using the Earth center of mass as the origin of our coordinate system, as opposed to some point in the middle of a farmer's field in Kansas. Again, in the 90s, predominantly, we had GPS, so we started to do these HARN networks. When we started to do, when we started to incorporate these continuously operating reference stations, or cores, now we had a network of stations that were operating 24/7 throughout the entire country, coast to coast. And we were processing this data between these stations on a daily basis. And what we very quickly saw was a disconnect between this cores network and our HARN networks, okay? Because remember, our HARN networks were built sort of piecemeal. You could look in the Northeast, it was in the 90s, and maybe, you know, in the Midwest, it was in the 2000s. And so there was a mishmash of different data from different times that were sort of connected, but not really well connected. So we really saw this disconnect. So the 2007 adjustment, essentially, it readjusted all of our GPS data within the United States and tied it all directly back to cores. So cores now has become the backbone of our coordinate systems. So NAD83 2011 was done specifically to remain consistent with cores. We had to do a readjustment of cores due to a number of things. For instance, plate tectonics or intraplate tectonics within the North American plate and the North American and Pacific plate. In order to keep the cores network consistent, we had to readjust it. Therefore, we had to readjust everything that was based on it. So along with those different datums and realizations, we have different levels of inferred accuracy. So you can look on a network scale, sort of where these systems fall, and then also on a local accuracy. And local accuracy, we probably aren't much better than what we always have been, although we can attain those accuracies with much more ease today than we could previously, based on the instrumentation and the technology that we have available to us today. But obviously, as you can see, now that we're able to measure across the country, that we have a much better accuracy on a network scale. As a matter of fact, we have network accuracies that really are approaching the level of our local accuracies. So that's what we have available. So the question is what do you use? Okay, what do you use in Vermont? And some folks say, well, I use NAD27. Well, occasionally we do. We have a need to ingest older data. Many folks say, well, I use NAD83 by statute. That's what we base our data on, NAD83 Vermont State Plane Meters. And I say that's great. Which one? And this is where it gets a little bit tricky. Depending on the coarseness or the resolution of our data, any one of these might be okay if its definition is ignored, right? I mean, if you're doing meter level positioning, you could say NAD83 and you sort of wouldn't be incorrect. It wouldn't really matter which one of these realizations you were truly tied to, because within a meter, it's sort of floating around in there. But the reality is that each one of these are different. And as we'll see, certain components of these become, especially when we start talking about things like LiDAR, becomes very important when we start to incorporate this data into GIS products. So we had our NAD83 86 to 92. That was about, depending on where you were in the state, could have been a ½ meter or more shift between those two. Okay, NAD83 92 to 96, not as much. We're looking at maybe 5 centimeters. And then we're really up here in the few centimeter, or centimeter, couple 3 centimeter range on these last realizations. That may or may not be important to you. However, I think just and we'll get into the metadata aspect of it, but it's become extremely important to incorporate this information into the products that we use. or the products that we develop. Some folks say that they use WGS84. I would dispute that. That's a whole nother discussion. But if you did, in fact, use WGS84, again, which one? Now, you might not use it. You may not care. But if we're looking at transformations, and you're saying, oh, here's this transformation from WGS84 to NAD83. Well, I hope you can appreciate right now that that isn't as simple as what it appears. So having a good idea of what your data is truly tied to and what you're trying to portray your data in makes a difference. The transformations are not all exact. They aren't, you know, it's not one size fits all. Again, in the international frame, you've got the International Terrestrial Reference Frame or the International GNSS frame, the IGS frame. And again, there's a number of different ITRFs. The current ITRF is ITRF 08. We've had many different ITRF versions. We've had and corresponding IGS versions, which is just the GPS component of the international frame. So as you can see, there's a lot of moving parts here that that we need to try to get a little bit of a handle on in order to address some of the data we collect and how we maybe transform or represent that data. Just to say this, okay, all of the work that we do, and if you use GPS in your projects, you do as well. You don't know you are doing it, but you are. Is that you're using the ITRF or the IGS 08. The GPS does not work in NAD83. It works in an international three-dimensional Cartesian coordinate system based on the reference frame for the satellites, and then it does transformations down to your local coordinate systems, in this case NAD83. So ITRF is what's really being used in the initial calculations. So if we look then at a brief, really quick difference between NAD83 and ITRF, this is where we stand today. Okay, back in 1986, NAD83 and the international frame were essentially the same. The ellipsoids are essentially, the WGS84 ellipsoid and the GRS80 ellipsoid are essentially identical with a very minor difference, but for all practical purposes, they are identical. But as we've gotten a better understanding of the Earth's center of mass, the international frame has migrated. It has moved as we've got this better understanding. And for probably political reasons, if nothing else, we've left NAD83 alone because, again, it would mean us changing. Every time that they put out a new ITRF, for us to put out a new corresponding NAD83 would be very difficult to do that throughout the country for, you know, to update statutes, to update laws, to update all of your contract specifications, et cetera, et cetera. So we've left it alone pretty much, except for when we've absolutely had to do something. Okay. So if we look on a national level or you know, a continental level type, this is what we're seeing. These are movements within IGS. So these are movements within the North American plate. So you can see, you know, we're up in the Northeast here. We're moving at, you know, a couple centimeters, 2.5 centimeters a year, maybe. That's how the plate is rotating or moving up in our neck of the woods. Okay, so that's just a zoom in. We also have this vertical component. Okay, so you can see mostly up here in the Northeast, there's some vertical uplift. That's a direct in direct response to, you know, 8, 10, 12,000 years ago, you know, we still had a mile of ice on top of us. So you take that ice off and the Earth's crust is still rebounding. So what we're seeing here is isostatic adjustment. So then even within NAD83, okay, which is our stable North American reference frame, right? I mean, that's what NAD83 doesn't move. Well, the reality is that we either have a combination of local motions. Obviously, the vertical is still localized, okay? That's real motion. Some of this might be real motion that we're seeing, okay, in the horizontal, and some of it might just be residual motions left over from our inability to completely remove all motions within the plate. So it's a very complicated process, not one that I'm schooled in, but in order to truly make it a net zero rotation is difficult. So there could be some residual motions left over, but they're obviously, as you can see, they're not all systematic. Some are moving in different directions, so those could actually be, in fact, real motions. So now let's look really quickly at our vertical datums. So we had NAVD or NGVD29 to begin with. Most folks are familiar with that. It's been around and still around in some degree. By definition, it was fixed 26 tide gauges in the United States. It didn't account for local mean sea level variations, okay, meaning that as we go up along the up and down the coast, sea level, it's a local phenomenon. Sea level in one place is not the same as sea level a mile up or down the coast, because sea level is affected by salinity, temperature, sea surface topography. There's all these things that come into play. So zero in one place is not zero in another. So for us to pick 26 tide gauges and call them all zero, though it appears logical on the surface, it's not, because they're not all zero. So essentially what we ended up doing was taking all of our network of leveling data, fixing it to these non-zero zeros, and then warping our data to fit it across the country. So that was essentially what we had with 29. And so for a number of different reasons, we looked to define a new vertical datum, which was NAVD88, North American Vertical Datum of 1988. And we said, we're just going to hold one point fixed. That way, we're not going to hold all these different stations fixed. Okay, so we did many thousands of kilometers of additional leveling. New benchmarks got put in, and so that was how we realized our datum. Our datum, in order for us to truly tie to NAVD88 today, we have to go out and touch a piece of brass, right? We got to go touch it, set up a level on it, set up a total station on it, set up a GPS receiver on it. We need to occupy that, and that's how we tie to NAVD88. But NAVD88 in itself has a couple of problems. We solved the local sea level variation problem by fixing only one height in the adjustment, as opposed to multiple constraints. But what this did was it allowed the use of that one fixed height to allow cross-country buildup of error. So I think anybody who has ever done measuring knows that every measurement has an error. And if you add measurement to measurement to measurement to measurement all the way across the country, eventually you can accumulate a lot of error unless you have some way of adjusting that out. Well, if we only have one constraint, which in this case was up in Quebec, you could see that by the time that you get to the Pacific Northwest, a whole bunch of error potentially has been accumulated across that network. And again, we thought we had the zero surface correct. For a number of reasons. It wasn't. Some were intentional. We won't go into those today. It was close, but it wasn't exact. And so the last piece of this that goes into our NAVD88 is if we're using GPS or GPS in some other remote sensing, i.e. for instance, LiDAR, in order to determine our orthometric heights. So essentially this is what we have, where we have the H is the height above the ellipsoid that we measure with GPS. That's what GPS gives you directly. Okay, we have our orthometric height, which is relative to our zero surface, which today is NAD83, but in this case, this is our geoid. Okay, so we have our today it's Geoid 12B is the name of the geoid model that NGS produces. And if we subtract, or in this case add, because the geoid height is a negative number. If we add this, okay, that will allow us to calculate what our orthometric height is. Okay, so big H is equal to little h minus our geoid height. Okay, and the only reason I'm really bringing this up is because this is how we're going to be defining our orthometric heights, or our new vertical reference frame in the future. So an understanding of that. So some of us are already getting into this today. If you're using LiDAR, you will see probably that it's referenced to some height system. It might be an NAD83 ellipsoid height, or it could be an NAD83 2007 ellipsoid height, or it might say NAVD88. Okay, so I'm not sure how your data's come through. I suspect it comes in many different flavors, but ultimately there was a relationship there somewhere. Okay, so if they collected the data and they were using NAD83 2007 as their coordinate system, their ellipsoid heights would be referenced to NAD83 2007, and they would have had to have used Geoid 09 in order to produce your NAVD88 height, or the height that you see to determine which way water flows, right? When you're developing your contours, that's what you want to know. So the purpose of this slide is just to show that there's a direct relationship between which ellipsoid height your data is collected in and which geoid model gets used. So you could see if I used if I was getting today's ellipsoid heights, NAD83 2011 ellipsoid heights, and I used an old geoid model to do that vertical transformation to NAVD88, I could end up with many centimeters or worse of error, just because I have used the wrong, unknowingly, but I've used the wrong geoid model for that transformation. So the relationship here is important, and I had asked Ivan, and we were yet to come up with a definitive answer, but and it's great if someone online knows the answer. I'd love to hear about it, either at the end of this session or offline. But how the GIS products deal with LiDAR data, and if you want to portray that data in NAVD88, but the data was collected in some ellipsoidal height system. So here's where our problems are. Okay, so NAD83 is not geocentric as it should be, right? We saw that little diagram that shows that it's really offset from where it should be by about 2.2 meters. We don't see that yet, but it won't be very long. But what your average citizen will have their Ronco Pocket GPS receiver / fishing pole. They'll go out with the availability of 30 satellites, and they'll get a position autonomously in their backyard to about a decimeter. Now that 2.2 meters shows up big time. Right now that 2 meters is in the noise range of what autonomous positioning will give you. Okay, even using WASP corrections, it's still about in the noise range. Okay, so it'll be this will be very evident in the not too distant future. NAD83 is not really well defined with positional velocities. Okay, the biggest problem though is with our vertical. NAVD88 it's realized by passive control. And you folks may not use benchmarks often. You may not, but the surveyors and engineers who develop systems that tie into the data that you're using do use those benchmarks, and it's it's the way that that all of the vertical products maybe a few generations back, but at least that's how those vertical products that you folks use were developed, by tying into these benchmarks. And the reality is these benchmarks are ceasing to exist on an exponential scale every year with construction and flooding and just wear and tear of the earth. A lot of these are disappearing. And even if they're not disappearing, we don't know if they're stable. The mark was set 40 years ago. It hasn't been leveled to since. Do you know that that benchmark is where it was when it was leveled 40 years ago, or 50 or 60 or 70 years ago? And the answer to that is maybe, but probably not. You know, the reality is if I leave a mark, if I level to a mark today, and I go tomorrow, you know, is it in the same place? Okay, so you know, and there's a lot of different things that affect that. It could be that isostatic adjustment that we were looking at. It could be subsidence, maybe here in Vermont, but definitely in other places like Texas and Louisiana, Arizona. And we have issues like sea level rise. So, you know, if we're supposed to be, if our vertical datum is supposed to reflect mean sea level, whatever that means, and sea level is rising, then do we ignore that within our datum, or do we try to account for that within our datum? So these are some of the issues that we have within our current vertical system. GRACE, okay, a satellite-based gravity mission, essentially allowed us to see this from a scientific standpoint. Data from GRACE has shown that our vertical surface is biased by about 50 centimeters, by about half a meter. Okay, and it's also proven to have that tilt across the United States of about a meter. And a good portion of that tilt had to do with that buildup of error that we have from leveling across the country with one constraint. I think there's some geophysical aspects to that as well, but I'm sure a large part of that is just the inherent error built into the leveling network. Okay, so I don't know why it's doing that. Excuse me, I'm going to bypass that one. There we go. Okay, so that's sort of what that looks like. So you can see, you know, where we are down here, and we see this very, you know, this trend, this tilt across the country in the zero surface of our vertical datum. So, you know, 0 and 0 are not the same. Okay, again, I think primarily here in this case because of the cross-country buildup of error. So set more marks, right? We could go back out, re-level the entire country, and do it all over again. And you know, that's a great idea. It put a lot of people to work for a long time, but it's not practical. And this is not a cartoon. This actually exists on a piece of old US 9 in Searsburg or Woodford in that area. But it illustrates that you know, putting more marks on the ground doesn't necessarily solve the problem. There's more marks, but what do you know about them? Okay, this is where we really need to go. We need to go to being able to essentially establish a vertical height when we want, where we want, to within certain limits, obviously. So NGS's mission, our goal by 2022 is to replace NAD and NAD83 and Navd88. Excuse me, provide centimeter access to all of our coordinates. And we are well on our way to doing that. This will be the new naming conventions of what we here in Vermont, at least the ones that are in red, will be using. So for the replacement for NAD83 will be NatRef 2022, North American Terrestrial Reference Frame of 2022. Vertically will be the North American Pacific Geopotential Datum, or NAPGD 2022. So you can see we're not calling this vertical. Okay, this is geopotential. What that means is that our vertical datum, our way of measuring heights, is based 100% on gravity. It has nothing to do with leveled measurements. It will be a gravitational geoid model. So gravity and an ellipsoid height that comes from NatRef 2022. So a combination of NatRef 2022 and Geoid 2022 will give us our NAPGD 2022 height. Okay, so our I'm going to say vertical. I don't want to, but I will. Our vertical datum is going to be based just on GPS observations and an ellipsoidal height from those GPS observations and a gravity field. Our future geometric frame, so course based, so it's based solely on our continuously operating reference stations. It will be identical to the IGS reference frame that's available in or about 2022 at some determined epoch. And when I say epoch, that means that, for instance, when we say today NAD83, NAD83 2011 epoch 2010, what that means is that that's the date that those coordinates were computed to. So if there's velocities involved, if I were to compute data today at today's epoch, I could apply a velocity that would tell me what it was in any other year by using those velocity models. Okay, so it's not just the datum, it's not just the datum tag, which is like the 2011 is the tag, but it's the epoch. It's the 2010.0, which says these are the coordinates that these dates were based or were created for. All of our passive control will be tied to the new datum, won't be a component of, right? The course stations will be the definition of the new datum. And really, and this is really the crux of it, is this constancy versus accuracy. Most folks don't want their coordinates to change. So that's the constancy part. But the reality is in order to keep them accurate, they have to change. If they're moving and we ignore that movement, you may have constancy, but you lose all accuracy. So it's a big trade-off, and our policy has sort of been to keep constancy until we can't ignore it anymore in order to gain our accuracy back. So we've gone through these little sort of steps in order to keep our coordinate frame adjusted. The future geopotential frame, gravimetric geoid base in combination with GNSS or GPSS. Develop the transformation tools relative to Navd88. That's an important part for all of us. Many of you have probably used NGS's vertical transformation tool, which is VertCon, vertical conversion. So that allows you to convert between NGVD29 heights and Navd88 heights. We'll develop a similar transformation that will allow us to go from Navd88 heights to NAVGD 2022 heights. So the only other part we have to do, I think, I could show you examples, but the reality is that today we can get ellipsoid heights out of GPS accurate to the centimeter with a little bit of work. It's not really easy, but we can do it. So the other part of that equation is finding this 1 centimeter geoid. Our goal is to define or be able to determine 2 centimeter orthometric heights. So that means that we can allow for a centimeter of error in our orthometric in our ellipsoid heights, and maybe a centimeter of error in our geoid heights. So this is the GravD program. Some of you may have heard about this, Gravity for the Redefinition of the American Vertical Datum. So essentially, it's an airborne, to a great extent, it's an airborne campaign using an airborne gravimeter to determine gravity over CONUS and all of our holdings in the Caribbean and Alaska and the Pacific. Okay, the bottom line for this is that we will redefine this H0 surface, and we'll hopefully be able to keep the gravity field itself or our tracking the gravity field up to date. And the reliance on our passive marks that are out there today will dwindle to secondary. So if you're in the middle of the forest and you can't use GPS to get your heights, you may go outside of the forest and find one, or maybe there's one of an older benchmark in the forest. Let's go with that. Okay, there's an old roadbed, so you found, or an old railroad bed, and you found this old mark. Well, maybe you could use that old mark and you use our new version of VertCon, and you can go convert it from the NGVD29 or Navd88 height to the Navd 2022 height. But NGS will have minimal involvement with those. We won't be maintaining those marks, and to the great extent, those are going to be used at your own risk. We're not saying that they're accurate horizontally or vertically anymore. You probably would have to truly verify that on your own if you were going to stand behind that and say, yes, these heights are in fact accurate. So again, our access to the new datum would be both horizontally and vertically. Okay, would be through the use of the CORS network and GPS. We'll develop this Navd88 conversion tool, as I mentioned. Okay, and that's in process right now, both from our standpoint at NGS, but many of our partners, VTrans, for instance, is actively using GPS out on their projects or in a special project, and they're obtaining GPS derived ellipsoid heights on existing Navd88 benchmarks, which will then go into will help us to develop this transformation tool. So through their efforts, the transformation tool in Vermont will be high resolution and should provide good conversion. So what kind of changes do we expect to see? Well, here's our approximate horizontal change from the North American plate. So we can see we're in the about 1¼ meters thereabouts. Okay, horizontally. Here's our ellipsoidal height changes. Oh, I'm sorry, we don't want to look at that. Here's our ellipsoidal height changes. Okay, so we're looking, I don't know, where are we here? Again, and in the 1¼ meter, probably in that vicinity. Our orthometric heights, so the heights that we use for determining or showing the direction of water flow. These are the type of heights that we're looking, or the type of changes we're expecting to see across CONUS. And a little bit of math tells me this is what I'm expecting, let's say in Montpelier. So those are the types of changes I'm expecting to see. Not an exact number, obviously, but an approximation of what I think the changes locally would be. So metadata, I think this is just about out of time, if I'm not quite out of time already. So this is what I want folks to take away from this. All of your positional metadata really needs to include things like datum, epoch, and source. Where did you get the data, and not just where did you get it, but how was it collected? I find it fascinating today that surveyors included will say, well, here's a coordinate for this marker, and it's NAD83 state plane. Say, great, how'd you get that? Well, or how was it determined? Well, and because they say, well, I went out with GPS and it's not close. Well, how was that coordinate determined? And you go back and you look and say, oh, it was from an old survey that was done in 27 with a transit and a tape, and it was converted to 83, and then it's something else, and it's like, okay, well, if you're within 1.5 feet, you're doing pretty good. Okay, so just because something has a current datum tag doesn't mean that it's accurate, and just because it doesn't have the current datum tag doesn't mean it's not accurate. So keeping this information specific to your project is going to become more and more important if you want to know how to move your data through time, through systems. It's going to be critical. Again, and the method in which it was done. I mean, it was data, elevation data. Well, was it done through LiDAR? Was it done through aerial photogrammetry? Was it done through, a surveyor? All of those have their own inherent levels of accuracy, or at least inferred levels of accuracy. The other thing is maintain your original data. I see many times folks, they keep their derived products, they don't keep the raw data. If you have the raw data, you can always go back and reprocess it. If you have the derived product which is already based on some kind of a model, then all you're stuck with is more transformations. So I encourage folks to hang on to your original data, whether it be survey data, whether it be LiDAR data, whatever that is. Keep your raw data. And the last slide I think I have is state plane coordinates, and I know that Ivan's going to speak more about the statutes and some things for that. The one thing I do want to point out is that National Geodetic Survey, along with the National Society of Professional Surveyors and the American Association for Geodetic Surveying, have created model language to share with all of the states to help the states make this change within their statutes. So it tries to keep it generic and simple so that it doesn't specify NAD anything. It maybe says more what the current accepted national coordinate system is or whatever, but at least it provides some guidance to help get us started down the road. And with that, I'm going to let you turn it over to Ivan, if you would like.
Okay, thanks, Dan.
Thank you.
And I'm going to hand it over to Ivan.
Okay. The headset gear is getting squared away here. Can everyone hear me?
Yes, we can hear you.
Superb. Again, I am Ivan Brown with VCGI, and well, first of all, I'm going to show my screen. And I am the database administrator here at VCGI. I'm going to present on how the datums and datum versions have impacted VCGI and VCGI's strategy for dealing with the issue going forward. This is an important subject because we have hundreds of data resources that are available just through the Vermont Data Portal and elsewhere. Organizations are so data rich now with the accumulation of data sets that has occurred over the past couple or 3 decades. There is a lot of data out there, however, not all of it is well documented with respect to spatial reference. There are some users who may not have an awareness of coordinate systems and datums. Maybe they're just grabbing data and working with it, while other users are well aware. If you aren't aware of it and you do get some data and then spin it off into a derivative and keep maintaining that derivative going forward without paying attention to the datum, there could be an adverse consequence down the road depending on what the purpose of the data is. I'll move this along. Again, there is a statute that specifies something called the Vermont Coordinate System, and it has 2 branches of language. It describes a Vermont Coordinate System 1927 and a Vermont Coordinate System 1983, and I think many of you know where this is headed. The Vermont Coordinate System 1927 means that we're using NAD27, and Vermont Coordinate System 1983 means that we are using NAD83. The statute is old, or the language, most of it in there is old, so it's not elaborating on NAD83, it simply says NAD83. The statute does specify the spheroid and the ellipsoid that are in play here. However, it doesn't go deeper into the important numbers with datum information. It does state that coordinates must conform to monumented points. And also, the more common term for this type of coordinate system is the Vermont State Plane Coordinate System. That's what we say around here in the GIS world all the time, and that is synonymous with the statute language Vermont Coordinate System. The statute states that projects that commence after January 1st of the year 2000 are to be in the Vermont Coordinate System 1983, and that we are not to be using 1927 anymore after the first day of 2000. That goes way back, doesn't it? And I've been with VCGI for almost 5 years now, and I should tell you that I haven't seen any data yet here that is still in NAD 27. The statute says that if you use these terms, such as Vermont Coordinate System 1983, the use of that term is limited to coordinates that are based on that system's definition. The statute chapter where all of this is laid out was last revised back in 2007. However, I did not see anything in there that indicated that the revision was at all related to datum version. Tangential to the statute are Vermont GIS standards and guidelines. Here in Vermont, we place a lot of importance on establishing standards for the use of GIS to make GIS work better in a multifaceted environment. We have a standard for the coordinate system, and the standard states that we are using Vermont State Plane Coordinate System, NAD83, with a unit meters. That standard is dated March 1998. The document, or the standard document, encourages migration from NAD 27 to NAD 83, and obviously VCGI did a good job with that because I haven't seen any NAD 27 data around here. Again, the standard, the GIS standard coordinate system, goes way back to '98 when we were dealing with Y2K issues and Bill Clinton was in office. A lot has happened since then. Google Earth came out and the smartphones came out. GPS technology became very predominant in the civilian market. Data has been collected through phones and through handheld devices, through GPS, but maybe remapped as a mashup to these modern web mapping applications which use mostly a Web Mercator auxiliary sphere spatial reference. Now with GIS software, there are pop-ups that present transformation issues that we did not see before, now that there is a 2007 version, NAD83, and a 2011 version. Some of these transformations are composite, and I had to read some of these transformation paths 2 or 3 times to see what is going on there. Again, we have a lot of consumption of data through Web Mercator, through these modern web mapping applications. The GIS consumer is no longer the GIS analyst. It's really everyone now. However, the data that's being fed to the Web Mercator map can come from a medley of spatial references. So in the 21st century now, we're tying all of this together and mashing up data. Meanwhile, the science with the datum is getting better, and the world is changing. The continents are moving around. Therefore, we need to keep up with the times. Our current situation goes like this. First of all, at VCGI, we use the term master data a lot, and the master means, well, it's master, it's the source. Most of our master data is in NAD83. We call it vanilla NAD83. It is not the 2007 version or 2011, just vanilla NAD83. Or in some cases, it retains the spatial reference as delivered. There are cases when we take data from somewhere else, like maybe a federal source, and project it maybe from a geographic coordinate system into state plane, and then we do at that point consider that projection result to be the master data, and we do document, or we should, and I've seen our metadata, we do a good job with documenting these projections that have been applied to the data, which is good and is on accord with what Dan was presenting. A lot of our data holdings here at VCGI are in the Vermont Imagery Program, also frequently called the Vermont Ortho Program, or VT Ortho. Historically, these deliveries of aerial imagery have been in NAD83. However, we are starting to get data in NAD83 2011. The Vermont LIDAR program is where we really get into big data, and we have raw LIDAR data deliveries, the LAS files that are in a medley of spatial references. Some is vanilla NAD83, while others are in the later versions. And we do keep the LAS files in their delivered spatial reference. And again, these three squares up here in the top level of the slide, this is really focusing in on the back room, the master data. Meanwhile, there are many consumers of our data resources. And here's where some interesting things happen. We do produce derivatives of our data, or exports of it, such as downloadable shapefiles. Those are typically provided in NAD83. And web services, that is a huge part of GIS nowadays. Again, data comes from a medley of sources and gets mashed up into that web Mercator presentation. VCGI does serve out web services, and most of them are offered in two flavors, plain vanilla NAD83 or web Mercator. Now, the consumer is getting it through web Mercator, for example, while the underlying data that the web service is calling may be NAD83 in the back room. There might be a transformation that is occurring on the fly there, or there should be one. And yes, we tend to trust our software and trust the math that happens behind the scene there. And after seeing Dan's presentation, I'm curious about that. I would like to look into what exactly Esri does with their transformation math. Are they getting the math from a legitimate source? I actually have a note on that here. I'm looking for it. The NGS provides vertical transformation math, and I would like to think that software companies are taking that math and putting it into their code base so that these transformations are reliable. We also have an open data or open geodata portal at VCGI that serves out data that VCGI manages, as well as data provided by partner agencies and organizations. And again, the portal is focused on NAD83. For example, if you get a shapefile through the portal, it is likely going to be in NAD83. If you find a web service in the portal to use in an app or software, it's going to be in web Mercator or NAD83. And sometimes it is available in both. I'm and present on our strategy here. We do have a strategy. And first of all, we will continue to be way more than casual about datums because we are VCGI and we're supposed to be more than casual about it. And we are supposed to connect subject matter experts like Dan to the GIS users so that we don't do anything reckless with data. And I should tell you that VCGI has about 450 individual data sets or data resources, and in addition to that, there are more than 200 data sets available through our federated partners, which means other state agencies and in some cases organizations that are outside of state government, such as regional planning commissions. We are going to continue to respect the concept of master data, and in most cases we are going to keep the master data in the datum as it was delivered. Still, users sometimes need to consume through Web Mercator or something else, and we will make products and services that are suitable for those uses. The statute does need modernization, and we are going to work on that. We don't know how that will look, and we will involve surveyor subject matter expertise with that, of course. And we do anticipate a mass reprojection project in the future. This seems to be a time that is similar to the late 1990s when there was a shift from NAD27 to NAD83. Now we need to identify when it will be appropriate to spend a lot of money on reprojecting our data or doing whatever we are going to do with our data to stay on accord with the times, with the datum versions and the new datum. And I just learned a new acronym. I'm going to turn through my notes here. The NATRF 2022 and NAPGD 2022 spatial references. We need to be ready for that, and we're expecting something big, some kind of big effort to be required for that. Finally, the last slide, and this provides us with an opportunity to have some questions and discussion as you look over some key VCGI and State of Vermont GIS web addresses. Also, my contact information is here should you want to reach out to me offline. At this point, I yield back to Leslie.
Okay, thanks, Ivan. The first question is just John would like a clarification of what you mean by vanilla NAD83. He says, do you mean that various epoch dates may be used rather than just one?
Well, this is Ivan. Thanks for the question. I'm not sure exactly how to respond to that. My impression is the term epoch is a new technical term in geodesy that's really applicable to the versions of NAD83 that have recently been coming out, as opposed to the original NAD83 from, I think it was 1986. My impression is we're talking about the 1986 NAD83.
Okay. And Dan, you're
Ivan,
unmuted.
actually,
Yeah, go ahead.
Yeah, great, thank you. Yeah, Ivan, if I could jump in, because I was thinking the same thing when I heard you use the term vanilla NAD83, and you were using it relative to LiDAR, which tells me it's probably fairly new data that's been collected. So my impression is, or my guess is that the data came in and it said NAD83. It was probably tied to a newer NAD83 realization, but the metadata didn't so indicate. Would that be a possibility?
It's probably a possibility. I would like to think that that did not happen. However, I can see something like that happening. We do have LiDAR deliveries that come through different routes, and sometimes there's a specific type of post-processing and maybe projection that occurs before it finally reaches our door. Sometimes it's grant funded or managed by someone else, and so we don't get into those details.
Yeah, just my thought on that was that the source of the coordinates these days are probably GPS through a real-time system of some kind, and for somebody to take a newer coordinate data and turn it back 2 decades just seems sort of counterintuitive. So, but yeah, I appreciate John's question. I was thinking the same thing.
Thank you, Dan. And again, one of my big takeaways from Dan's presentation was that metadata should capture the datum and the epoch and the source, and that if there is a metadata template that is being used, don't just look over that. Fill it in properly, because those are important elements.
And I think that you guys have stunned everyone with information, because I'm not getting any other questions. So just in case anybody didn't hear, this is your opportunity to ask questions of Dan, Martin, and Ivan Brown before we wrap up the webinar.
Well, this is Ivan. I have a comment on this. Dan's presentation was very rich with content, and I really appreciate it. And what I might do, and this might be a good suggestion for others, is go back and get his presentation. This is being recorded. This will be on YouTube. We can go back and look at that again and maybe get a second pass or third pass over the presentation and maybe jot down some questions for Dan or for a surveyor friend or someone who works with geodesy and learn more.
Yeah, thanks, Ivan. And I wanted to make sure too that everyone understood too that after this is done, if you do think of a question or have related questions, certainly feel free to I can send my presentation to Leslie or make it available through other sources, but certainly feel free to reach out to me, email or phone call. My info is all on NGS's website, my contact info, and I'm more than happy to do what I can to answer any questions.
Great. I don't have any questions, so we might wrap this up and let people send their questions in separately if they come up later. As Ivan suggested, everybody can take a look at the recorded webinar if they'd like to, and they will see the relevant contact information, I think, in there, as well as the posted PowerPoints being on our website. There's a few thank yous coming in now, so I think we're all set. Thank you very much, Dan Martin from the National Geodetic Survey and Ivan Brown from VCGI, and I hope everybody has a great day. Thanks.
Thanks, Leslie.
Thank you, Leslie.
So then once you put it in here,